we're going to be looking at what we call 30, 60, 90 triangles because those will be the angles contained in the triangle. And they will always have a particular, it'll have a particular proportion or ratio of sides. And you could use the pattern, but we could also use a reference triangle. So we're going to do this with reference triangles. Makes the process easier to teach a lot of people at once. So just like we had learned a reference triangle for 45, 45, 90 triangles, 30, 60, 90 triangles will always have a right triangle, the 90, and across from it will be the biggest side. Biggest angle, across from it is the biggest side. Then you'll always have a 30-degree angle, which is the smaller angle, we can tell between the two. And across from it will always be the smallest side. And across from the medium one would be the 60-degree angle, and across from that will be the larger of the two sides. And again, like we said, the hypotenuse is across from the right angle always. It's always in that position. Okay, across from the biggest angle is the biggest side. So in doing this, we're going to use a reference triangle pattern. The small side is in comparison to whatever it is, let's call it 1, will compare to the hypotenuse because the hypotenuse will always be twice as big. It's a 2-to-1 ratio. So if we were to take this shape and draw it again, what that means is if this was 8, well then this will be 16. So sometimes when we know the small side, we can just double it to get the hypotenuse. If it was, 4, it would be 8. Or we could work backwards. If this was 10, we could work backwards and get 5. Even if it's not a whole number. If it's 5, we can get 5 over 2, half of 5. Okay, and then the proportion, well, because of the Pythagorean theorem, if we don't know the large side, we would know, right, x squared plus 1 squared equals 2 squared. X squared plus 1 equals 4. When we subtract 1, x squared is going to be radical 3. So x is going to be, or the square root of x squared. So x is going to be radical 3. So that will be our final number in our pattern. It's always going to be, it's easy as 1, 2, 3, but it's 1, 2 radical 3. So you might even think to yourself, why is radical 3 there? I thought the biggest side is the hypotenuse. Now remember, it's not 3, it's radical 3, square root of 3. And that's about 1.7. So it's really 1, 1.7 to 2. So when we put back the triangle, if we did it again, we could look at a comparison there as well. When this number is 8, this will be 8 square root of 3. And this will be double, 16. Now we don't always have things so easy. For example, we might have a starting point with the square root here. Okay, then we would need to know how to get to the next one. It would be that times square root of 3. So whatever it is, it'd be that times square root of 3. So a lot of times what we'll do is we'll learn this pattern. It'd be x, 1x, 2x, radical 3. But we're going to be using what we call a reference triangle to solve ours because it's again a part of our similarity chapter and we want to practice matching similar parts and solving. So the small side will always be 1, the hypotenuse 2, and radical 3 is the long side. So I'll always say large or small or long and short for the two sides. The hypotenuse, we always just call it the hypotenuse. So we never consider it the long or short side. It would be considered something special. It has its own name, hypotenuse. Hypotenuse is Greek for underneath because if we rotated it, the hypotenuse is underneath the right angle. So hypotenuse was a word that meant underneath. So I actually looked that up today. I was curious. All right, so let's practice solving these with our reference triangle. We can take a new sheet. And let's start off right away with one that's not too challenging. So let's say we have, this is 10 and we want to find x. Okay, what I always recommend is we label. So this is the short, Eventually I just use S and L instead of writing the whole word. This is the long side. We always need to notice because you can't just write the number anywhere. And then this is the hypotenuse. So I like to start by labeling. We'll quickly draw our reference triangle. I like to remind students how to draw it is you make an L, because remember there's a long and a short side. And then make the hypotenuse. So we're always going to use this reference triangle 1, 2, radical 3. And we're going to match or compare sides. So x is going to go with the long side, radical 3. Radical 3 is always the long, the shorter of the two, and the hypotenuse. And then if I were to color it, the radical 10 is the hypotenuse, goes with radical 2, the hypotenuse. So I'm going to set up a proportion. X goes with the radical 3. They're the similar proportion because they're similar triangles. 10 goes with 2. 10 goes with 2. And we cross multiply. So first we need to set it up using our pattern, our reference triangle. 1, 2. I always exaggerate how long the long and short ones are so I can tell the difference when I make my reference. And then we're going to cross multiply. So we've been doing this for a while in my class. We should know we multiply this way, 2x equals this way, 10 times radical 3. And we want to get x by itself. We do the opposite, we divide. X will equal 5 radical 3 because 10 divided by 2 gave us 5. The 2 cancels out. So we can set this up and cross multiply. So let's try another one where we're given a whole number on the long side, because a lot of times you'll end up with the square root on the bottom. So this is actually a very, well, it's similar. We're doing similarity. It's very much like the 45, 45, 90, only our reference is different. And we have to be careful because 45, 45, 90, the sides are the same. Here you need to notice which is the short side, which is the longer side. So let's try another one. We'll put the x here and we'll call this, let's just make it 100. So when I draw my reference triangle in my notes, when I was a student and when I'm teaching it, like I said, I always draw an L. If you want to exaggerate it, you want to always point out the fact that there's a short and a long, short, long, and a hypotenuse. So the short is 1, 2 is the hypotenuse, and radical 3. What many students do, I've noticed, it's a good idea, is they'll just match them and put it right underneath the starting problem. So x goes with radical 3, and 2 goes under the 100 because those are the matching pieces. This matches with this, the 2, and the x matches with the long side, radical 3. And then they just do crisscross that way and start doing their work. So it just saves them, you know, one little space. So I'll just rewrite it. X over radical 3 is 100 over 2. When we cross multiply, we get 2x equals 100 times radical 3. 100 times radical 3. So we again divide by 2. That won't always happen. So we'll get 50 radical 3. So sometimes they're going to rotate or reflect, so the triangle will not face the same way. So again, we're going to have to be careful. We notice which is the long. Oh, I didn't even label it. So normally we'll label it. Long side, hypotenuse, that's why we match them. This would be the short side. There's nothing there. So I'm going to show you, well, what if you have two letters, an X and a Y you're looking for? You just do one letter at a time. So we could always only work with one variable at a time. So let's make it face a different direction. This is 60. I was going to make it 10 and then I made a funny looking 5. So anyway, oops, make it 50. Call this X, call this Y. So now we have both letters and it's going to work the same way. We'll just ignore one of the letters. So pretend that the X is not there. So we always want to draw or have our little reference triangle to look at. Again, our short leg, long leg, and our hypotenuse. Oof. Not a very nice looking triangle. So our short leg's 1, 2, radical 3. And so I always recommend you label so you're clear. Short, here's the long leg, and here's the, oop, nope, see I made a mistake. Hypotenuse is here, across from the 90, so that's the hypotenuse. That's the long leg. Long or large, I've used both words. So we're going to be able to match them, right? The short leg goes with x, the hypotenuse goes with 2, the y goes with 2, and then the long leg, 50, will match with the radical 3. So let's take a look. We'll just pick one at a time. So like I said, let's ignore the x for a moment. We'll just deal with y. So y matches with the hypotenuse with 2. The long leg matches with radical 3. The short leg matches with 1. So I'm going to have these fractions to make cross-multiplying problems, but I can only do one letter at a time. So some people take this, x over 1, y over 2, and they say, okay, I can't, what do? I have 3 of them. So we just want to ignore one of them at a time. So ignore the x. And we'll do this one. So we now can cross-multiply. So we always use one variable and the other one has both numbers. It's not a variable. So y radical 3 equals 2 times 50 is 100. So just like we say 2y, this means times. So we divide both sides by radical 3. 2x means 2 times x. And y radical 3 means y times radical 3. And when we divide both sides, that cancels. And we get 100 over radical 3. So those of you who are familiar with rationalizing, that's a separate lesson. If I remember, I'll put it in the notes. But when we rationalize, we bring the square root up. So we need to multiply the top and the bottom by the same square root. And we end up with 100 radical 3 on top now. And the bottom becomes normal 3. Radical 3 times radical 3 is 9. Radical 9, which is normal 3. So now that we found y, we just do a completely separate problem to find x. So we have x goes with 1. And we have 50 goes with radical 3. And when we cross multiply, we get this x radical 3 equals 50. So then again, we want to get x times radical 3 to release the radical 3, so we do the opposite. We divide by radical 3. And so those of us who remember the next step, we cannot leave a square root. So we're going to multiply the top and the bottom by that square root. And we'll get 50 radical 3 over normal 3. So we want to make sure you can rationalize the denominator. Watch the video if you don't know how to do that. So, this video is assuming you've already done the reference triangle with the 45, 45, 90. So you're familiar that we're matching pieces. It's just now we have another piece. Instead of two sides that are the same, one is shorter, one is longer. And our reference triangle is changing. So let's do one more. We'll make it face even another direction. So sometimes when you have let me use my line drawing too. Sometimes when you have a 45, 45, 90 triangle, they're not going to give it to you in a way that it's facing the same way as your reference triangle. So you're going to need to notice that, which is why I recommend the labeling. So you can match the short one with the short one and the long one with the long one. So if it's facing this way, they're always going to let you know which one's the shorter angle because they have to let you know. Or you can just see it. If they don't tell you, they just tell you, hey, this is 40, 30, 60, 90. So this would be 60. That would be the longer side is across from it. This would be 30. Okay, across from that is the shorter side because across from the shortest angle is the shortest side. They work together. So let's say I want to find, this is 5 radical 2, let's pretend. And let's just do one letter, we'll find x. So x is the long side we want to make sure we notice, and this is the hypotenuse. I always recommend you label that one first, because then the other two is just long and short. So when I put in my reference triangle, I want to remember that the short one is 1, the hypotenuse is 2, but the long side is radical 3. Short, hypotenuse, and the long side. So we want to remember the long side goes with the radical 3. X goes with radical 3. And the 5 radical 2 is in the hypotenuse spot. So we're matching hypotenuse with hypotenuse, long side with long side. So 5 radical 2 will match with the hypotenuse, which is the 2 spot. And now we cross multiply. Now when we get 5 radical 2 times radical 3, we've learned and reviewed radical times radicals, whole numbers times whole numbers. So we get 5 radical 6. And then we divide by 2. And we get 5 radical 6, or square root of 6, over 2. And so we can kind of feel smart because we're moving around square roots and multiplying square roots and rationalizing denominators and cross multiplying. So we're doing a lot of good basic things to review. So make sure we ask questions, and it helps me to even remake a video and know what to add to it. A good question helps many people.